In order to create a smart contract, we're going to need some Ethereum to pay the gas to deploy it. However, we don't want to use real Ethereum for this exercise because that can be quite expensive. Instead, what we're going to do is use a test network. So open your MetaMask account, and you want to hit the drop-down over here and click Show Hide Test Networks. And this will show you the other test networks that are available: Ropstein, Coven, Rinkeby, and Goerli. Now, some of these networks are easier to acquire test ether than others. So for the purpose of this exercise, I'm going to use the Coven test network. This is what we have here. So make sure you go to faucets.chain.link in order to acquire some Coven Ethereum. Click Connect Wallet and hit MetaMask. Hit Next, Connect, and you have the option to obtain 0.1 test Ethereum. We don't need any link, and we also need to check that we are not a robot. Send request, and we will wait for this transaction to complete. Okay, the transaction has completed, and when we open our MetaMask, we will see that we have 0.1 Ethereum. This, of course, is Coven Ethereum, not real Ethereum. Now let's create the actual smart contract. We will go to remix.ethereum.org. We will click Contracts and do my contract.sol. Okay, what are we going to put in here? Well, this contract can just be something that users store a message to and other users can read it. The first thing we need to do is specify the Solidity version. Pragma Solidity 0.8.7. This, I picked 0.8.7 because this is what Remix defaults to. If Remix happens to be using another version, just pick that. Now, to create the actual smart contract, we're going to say contract, messages, and this you can think of as sort of being like a class in Java or a similar language. We will need a variable to hold our message, and we will make it empty for now. Next, we will create a function that allows us to set this string. This will look quite familiar. We will need to add arguments here that will contain the message that we are setting inside of our variable, and we will set the variable. Don't worry if you don't understand what this call data is. This is something you will learn about later in Solidity, but it's specific to the data type of string. Next, we will create a function that gets the message, and this is a view function because it's only looking at the state of the variable. It's not altering it like the other function is, and it will return a type string memory. Now, I know this memory keyword here might be a little bit unintuitive, but the way Solidity is architected is that strings are not stored on the stack. They are kept either in storage or memory or passed as arguments to a function. Don't worry about this technicality for now. We will simply return the message. Now we will click on the Solidity symbol and hit compile. It's giving us a warning because we have not specified a license, but that really doesn't matter. We're going to keep going. Make sure that JavaScript VM is selected and hit deploy. This is only deploying it inside of a simulated environment in the browser. It's not really deploying it on any blockchain. If we get the message, we're just going to get an empty string back. But if we set the message to hello metaverse, we set it and we get it and it comes back this way. We can also leave something more ominous like this, and the code behaves the way we expect it to. Okay, this is only running inside of our local environment here. We want to actually deploy it to the Coven test network. So we will hit the drop down here and hit injected web3. This displays the Coven network. This is what we got the original Ethereum for so that we can deploy it there. So we will hit deploy and MetaMask will pop up. We have to pay this Ethereum gas fee to deploy the contract, and we hit confirm. If you click view on Etherscan, you'll have to wait a while for this transaction to show up. But I want you to note that this is coven.etherscan.io, not the regular Etherscan, because again, we are using Coven Ethereum network, not the mainnet Ethereum. Okay, the transaction has succeeded and we can see the contract over here. Now we cannot interact with the contract right now because the smart contract has not been verified. So let's go ahead and do that. We used a single file and we used Solidity 0.8.7. The license type, there isn't any, and we will agree to the terms of service and continue. Now we will paste the code we had earlier into this box over here. Again, verify that we are not a robot and publish it. This has been successfully verified. Now let's go back to our contract. When someone reads the contract, it's going to be empty because the string has not been set. However, we can initiate an Ethereum transaction to set the message in this interface now. So let's connect to Web3, use MetaMask, and hit next. Click it again, and it connects. Under set message, let's put Jeff was here. And this is an actual Ethereum transaction that's being written to the blockchain, which is why we have to spend a little bit of gas and confirm it in MetaMask. If you look under data of what's being sent, this is what the function argument is. Jeff was here. So let's confirm. It will take some time for this transaction to confirm. So we will have to wait for it. And it has confirmed. So let's go back to read contract, refresh this page. We click get message and it says Jeff was here. And we can repeat this process and anyone can go to this particular address and write to the contract. They would have to specifically go to coven.etherscan.io. So we could repeat this process with the real Ethereum mainnet simply by going back to MetaMask and going to the Ethereum mainnet and repeating the process. Now, I don't have any real Ethereum inside of this wallet, and this would have to be filled up and we'd have to pay for the gas, which will cost real money. But other than that, the process is exactly the same.